Welcome back to the next one, cyclotron. In the previous, we discussed about how the helical motion is happening, right, inside the magnetic field. There are two components in the velocity we have, perpendicular and parallel. The parallel, there is no change as it along go with magnetic field, but due to that perpendicular component, it makes circular motion, right? And this perpendicular component is coupled with the parallel component, then only it will produce like a helical shape. And a very good example, if you look at some mosquito coils, right, which is look like circular, if you are seeing that will give a spiral in shape, right, helical in shape. And similarly, the same concept we are going to use here, the cyclotron. Actually, what is cyclotron means? We are going to accelerate the charged particles or ions. Okay, we are going to make accelerate. Accelerate means we are going to provide increase their energy, right? So if the energy is increased, it can easily go and bump up with some other things. So these cyclotrons are mainly used in nuclear reactions. So we are going to hit the fast moving protons in that particular element, and that will make some nuclear reactions and produce some amount of energy. So these kind of things we are going to use by using cyclotrons, right? Yes. Now we move on to the cyclotron topics. So the cyclotron, what is cyclotron? To accelerate the charged particles or ions at high energies. So main concept is at high energy we are going to accelerate. Okay. Who invented first? E.O. Lawrence and M.S. Livingston, who investigate about cyclotron while they were investigating about nuclear, right? And here in cyclotron, we are going to use both magnetic field and electric field here. Both are perpendicular to each other. That's why we are saying that cross field. Cross field means both magnetic field and electric field are perpendicular. That's why we are saying that cross field. And the frequency of revolution of charged particles in a magnetic field is independent of energy. So here the particles are revolving here, right? That revolution is independent of its energy. That's why I wrote here the revolution of charged particles in a magnetic field is independent of its energy, right? And what is cyclotron? How we are going to construct here. Now we move on to the diagram now. Okay. So this is the metal box. This is the metal box. Inside the metal box, I have two different D's, which is look like the letter D, right? And here also I have one more D. I have two D's, right? So these D's are located in a magnetic field, and these D's are free from electric field. Remember that inside the D's, it's free from electric field. Only the D's are in the magnetic field, right? Okay. And here we have magnetic field, and outside the box we are connecting the electric field. So what we are going to do, while operation conditions, we are going to change the polarities of the electric field. Due to the change in polarities, we will get some ideas from that, I will say, right? We are changing the polarities. Due to the polarity change, there is some energy increases. Therefore energy increases means automatically the circular path also is going to be increases, like the way the radius increases and ejected out at high energy, right? Okay. Now we have one oscillator here, which is alternative voltage, right? Alternative, it gives some frequency. So it's revolving, right? Inside any charged particles is revolving, right? So if it is revolving in the sense, it will also have some frequency, right? So applied frequency, and as in this one is we are saying that cyclotron frequency. If these two frequencies are equal, then we are saying that resonant frequency, right? So the frequency of cyclotron and the frequency of applied oscillator, both are equal. That time we will have resonance. At that time, this is D1 and this is D2. So D1 will be higher potential, D2 will be lower potential. So what will happen? Assume that this is proton right now. So these protons are moving here, right? So at D1, the sense high potential, and it will move to low potential, right? And in between we have some gap, right? Yes, of course, between two D's we have some small gap. Okay. Now, how this cyclotron is working now? Yes. Okay. Now, coming back to here, we have two Ds. Okay. Here I have chosen a proton, and inside this metal box, only the magnetic field is acting on that charged particles. So inside the Ds, only the magnetic field will be active. There is no electric field, right? We are changing the polarities of the electric field outside this metal box, right? Okay. And here the charged particles, proton here we have, right? Initially it goes in a circular motion. Why? Due to perpendicular component of the charged particle, velocity of the particle, right? So it makes circular motion. After that, what will happen? It makes cylindrical shape, right? Okay. Now here it comes to this D, right? Yes. Afterwards, what we are going to change, what we are going to do, we are going to change the polarity of the electric field. So for that, for example, here if you are giving a negative and here we are giving positive value, so we are going to interchanging the polarity value. That time what will happen? It will get deflected to another one D's. While reaches the second, this is D1 actually, right? This is D2. While reaching this D, again we are going to change the polarity. So the polarity changes is happening simultaneously. So that's why it gets deflected and it gets energy, more energy, right? And it's revolving and it gets more kinetic energy and it is deflected by this deflection plate and ejected out at high energies. So this is the way we are getting very good high energies of charged particles. We can set the velocity of the charged particles from the cyclotron, right? Okay. Now we are coming back to here. We have two Ds, I said, right? Yes. And the magnetic field acts on the charged particles, makes go around in a circular course. Only this magnetic field only make these charged particles in a circular motion. And the sign of the electric field is changed alternately. I said earlier, right? The sign of the electric field is changed alternatively. It ensures the particle accelerated by electric field. Due to electric field only the particles are accelerated inside the Ds, right? And acceleration increases means energy also is going to be increases. If energy increases means the radius of the circle also is going to be increases. That's why I wrote here, right? So acceleration increases, right? Energy increases, the circular also is going to be increases. At last we are getting ejected out and getting the very good high energies from this deflection plate and we are getting high energies, right? And similarly we have some derivation part to find out the frequency and like that we want to find out. Yeah, here we have some derivation part. We want to find out the time period of revolution, capital T, and the velocity, the kinetic energy as we said, right? Okay. And the charged particles move in a semicircular path. What is semicircular path? This is called semicircular path. Yes? And semicircular path of one of the Ds. One of the Ds means this is one of the Ds, right? So semicircular means this is also semicircular, right? And arrive in the gap between the Ds. So once it makes semicircle, it comes back to between the gap of Ds. That time to take the time interval of T by 2. And what is called T? The time taken for one complete rotation. Therefore, T is equal to 1 by nu c. What is nu c? The frequency of cyclotron. So nu c is called frequency of cyclotron. That is equal to 2 pi m divided by qb. Where we have seen this equation? Yes, the previous we have seen, right? The combined magnetic field and electric field. From that we are calculating centripetal forces. From that we are calculating the time value and frequency, right? So from that we have took this equation. T is equal to 2 pi m divided by qb. And nu c is the frequency of cyclotron. And the frequency of applied voltage VA is the frequency of this one. So as stated that will use the frequency of applied voltage VA is adjusted by the polarity of the D's is reversed. So we need to change the polarity of the is reversed in the same time, and if we are changing the polarities, what will happen? It covers in the half rotation, right? A semicircular path. So half rotation it will takes. So from that we at last we want to, its energy increases means obviously the radius of the circle also is going to be increases and ejected out. So we want to find out the velocity of the charge particles. V is equal to QBR divided by M. Where we have took this equation as previous, we have the combined form of electric field and magnetic field, right? So from that we have took this equation, V is equal to QBR divided by M. And kinetic energy, this is velocity. Kinetic energy is equal to half mv square. So 1 by 2 m. Instead of v square, just squaring all those things, q square, d square, r square divided by m square. So m and m square will be cancelled. So therefore we can write 1 by 2 m q square, b square, r square. So this is the kinetic energy of the charge particles. And what is the use in the sense? I said earlier, right? To study about nuclear reactions, radioactive element like that. Even in medicine field also we have some application point, like you will have diagnosis and treatment we have, right? So what are the uses in the sense? Nuclear reactions we have, and we can synthesize a new material, and radioactivity substance we can produce, which can be used in diagnosis and treatment in medical field. So these are the application point of cyclotron. I hope you understand well. Thank you. See you in the next video.